This is ClueCon Weekly, the official Free Switch web show produced and broadcasted directly from Free Switch. ClueCon Weekly features live updates from the Free Switch developers and presentations from various pioneers of communications technology. ClueCon Weekly is brought to you by Free Switch Solutions, the official consulting firm of the Free Switch open source project. Get help from the experts. Visit freeswitch.com. ClueCon, the premier technology conference for telecom, WebRTC, IoT, and all things maker. ClueCon is held every year in Chicago, Illinois, and offers an all-day hackathon and 4 days of technology-rich presentations from developers around the world. Learn more at ClueCon.com or call 877-748-CLUE.
All right, guys, welcome to ClueCon Weekly. Today is July 19th, and we're going to have Rich Neumann from Sub2R joining us today. If you guys aren't familiar with Sub2R, these guys are making a really cool 4K camera that's coming in at a really cool price point, and that's the goal anyway. And Rich is going to be joining us in just a minute to talk about that. Before we get to that, we're going to jump over to Mr. Brian West for the news.
Thanks, Ken. This past week, we released Free Switch 1619. Visit freeswitch.org for more information and see the changelog. I would also like to take this time to thank Dialpad, Bandwidth, and SureVoIP for coming on as ClueCon 2017 sponsors. And if you haven't done so already and you want to get involved in the hackathon at ClueCon, visit ClueCon.com. All the information about what's going to be taking place is available on the website, so you can get a head start. In addition, you can register for the OpenSIPs training or the Free Switch training at ClueCon.com. I'll be teaching the Free Switch training, so if you would like to get involved there, go to ClueCon.com and register. We'll be sure to include the links below. And that's it, Ken.
All right, cool. Thank you very much, Mr. West. So today we're going to get Rich in here. Let's see here. Let me go ahead and get Rich in here. Rich, how you doing today, sir?
I'm doing good, thank you.
So, where'd he go? Oh, there we go. That's more better. So we got Rich here. Rich, you work with 2R1Y, and we'll let you explain that later. And you guys are a group of engineers and just various tech people, and yourself. I think you came out of the financial background and everything, but you guys are working on a new camera that we hope to see on the market soon. What can you tell me about that camera?
Well, our core technology based on 2R1Y was designed to do high-speed 3D imaging. And part of the technology, required that we had a camera that gave us access to absolutely every piece of the imaging pipeline, from the moment the light hits the lens to the very pixel and all the way through the pipeline. We couldn't find one, so naively we said, oh, what the heck, we'll just build one, right? And so we built the camera, which was not an easy task. It's actually the one I'm using right now. It's this little 720p camera that will run up to basically 720p at 120 frames a second, and then downscale you can get 240 and 480 out of it. So it's a cool little camera. Built that, went back to working on our core technology, and meanwhile, Serge would every once in a while post videos about what our camera would do on YouTube. And about 2 years ago, we started noticing something interesting, is that people were knocking on our door and basically saying, hey, we need your camera. We need a camera that does that. And the more time went by, the more we realized that what we built was something that's really exciting for a lot of people. So we took a big step back and said, we're going to split the company into two parts. One is the core technology, and the other one is the camera technology. And let's go spend a year talking to people who want to use our camera and figure out what is it they want? What is it they need? What would just make them like the happiest people in the world if their camera would just do this? And what we found is that people want the ability to access and control all the aspects of the camera. I mean, right now, you know, people hold up a cell phone and they go, oh, this is my camera, but everything's locked away in an ASIC. You have no control over the optics. You have no control over what the image processing does. I mean, it's just basically you take a picture and it comes out the other end. Kind of like an old Brownie camera. That dates me, probably. I don't think anybody listening to this knows what a Brownie camera is. But anyway, so we took a step back and we said, hey, we're going to build this open architecture camera, and we're going to make absolutely everything accessible. So I don't know if you guys can see it, but we start out with a camera board. And the nice thing is the motherboard separates from the camera board itself. So you've got the ability to change the image sensor on the camera as easily as you would change a lens on a DSLR. We even made it such that the dual microphones are interchangeable as well. So you can swap those out if you don't want a microphone for low bandwidth data. And all of that gets interlaced on the video stream. So it's kind of a cool camera. And then we wanted to make sure that if people are going to use it, that we start out with a resolution and a frame rate that sets it apart. So this is a 4K, 30 frame a second, 1080p, 60 frame a second base camera. That kind of in a nutshell is what we got.
Helps if I unmute myself here. So now with this camera right now, what kind of outputs do you guys have on that? Is this going to be for like more for broadcast friendly, or more for, say, like me sitting here streaming games, that kind of stuff? And I want a 4K camera for my feed.
So the answer to that is yes. Our primary input and output is a USB 3.0C connector. But we also have a secondary connector, which is right now it's an RJ45 gig E connection. But we're ditching that when we go into production, I'm pretty sure, for an SPF cage, or SFP cage, I'm sorry. Too many three-letter abbreviations. We found a company that makes these modules that allows you to plug into the cage and convert the output signal into just about anything you want. So it can be HDMI, it can be gig E, it can be optical, it can be SDI, you name it, you can convert to it. We like that because it makes it easier for the end user to pick the format of the video that they want to stream.
Right. So you're just telling me that I can pretty much, once that SFP cage is in place, then I could plug it into, say, like a Blackmagic video switch, or into the USB port on my computer, or even into the Ethernet, so I could have 10 of these things and then pull the video back out and do whatever I want with it.
Exactly. And instead of us hardwiring that into the camera, we're using that cage as a kind of a universal port so that you can convert to any format you need.
Well, a lot of the other thing is, what about the glass on those things? I know, are you guys have changeable lenses on there? Because it didn't, when you held up the camera board, it didn't look like what I would expect out of, say, a Canon or something like that for the glass.
1 second. This I have to show up.
Uh-oh.
Nope, I'm back.
No, I think this is going to be something cool.
So that's one thing, is we like to have interchangeable lenses. I mean, basically, we did a lot of research, and what we picked was an M12 lens, because we found a company called Evitar that makes chromatically and optically non-distortion lenses for an M12 format, which is insane. I mean, these things are incredible optical quality, and they're very affordable. But if you don't like that, you can change the lens holder, and you can put any number of things on there, including we provide the support for powered optics. But if you're really adventurous, and you mentioned the word Canon, and I just had to do this, we mounted this on our camera.
Uh-oh.
So we started out with a standard speed adapter, and then we made an adapter that went on the end of that, and that actually fits and works on our camera. So What kind of glass can you put on the camera? What kind of glass do you want to put on the camera is really the question.
So really what it comes down to is just whatever glass we can find, and you have to have an adapter to that M12 format.
Well, you don't even have to have an adapter to the M12. If you get to a format that says that you want something completely different, the lens holder is only held onto the camera port by 2 screws. So you could replace the lens holder with a lens holder that supported anything. As we move forward, what we're going to try and do is to give the user the information necessary to correctly pick a lens or a lens adapter that is matched to the sensor they're using. So if they're using a low light, high speed 720p sensor on the camera, that would take one set of optics versus, say, for instance, a 4K on-chip HDR camera, which would use a different lens and a different setup. Our goal is not to hide anything. To give the end user as much information as necessary to customize and build this camera exactly the way they want.
Now, does that include the software also? Because if I remember correctly, you guys have an FPGA on board. So
yes.
Would the information be available to, say, modify that FPGA code or build your own custom firmware to address, say, a scientific or industrial need?
So we draw an interesting line. We are open architecture. We're not open source. Certain parts of the code will remain locked because that's our proprietary software that ties all the pieces together. But outside of that, we'll give you the hooks. We'll tell you where to implement your own code if you want to do that. We'll give you the ability. We have right now the ability to actually access the image sensor and reprogram the image sensor. So we give you access to the registers on board the chip itself. So as much access as possible, we're going to give you and tell you how to do that.
So that's super cool there. Now, one of the things that you mentioned a few minutes ago was low bandwidth data instead of audio. And now, is that something that schematic and stuff are available to make, an input for those for that spot on the camera board?
Yeah, we can give you the specs for all that. And so if you put this, for instance, into a deep sea ROV, microphones don't make any sense, right? What are you going to hear? Nothing, But you may want to know how deep were you? What was the water temperature? What's the salinity? What was your GPS location? Or, anything else you want to know. All of that data can be collected in low bandwidth data. Basically you're limited to what the audio channel will support. And we have a function we call interlacing, where the audio is split up into chunks, that channel is split up into chunks, and then it's interlaced with a video stream. So if you're looking at a video stream, you can actually pull the metadata right off the video stream and see what was happening in that exact frame of video. So in that moment of time, what was going on with the data you were collecting.
Okay, so then you could pretty much, if I can get it into the camera, then I can put pretty much anything in there, whether it's audio or just arbitrary data, as long as I can match that physical and signaling requirements in there.
Exactly. And again, was our intent, was to give people the ability to make modifications to the device to make it as useful as possible for the end user.
Yeah, that's really cool there. Now, go a little bit different direction here. When you guys were developing this camera, what were some of the big issues that you had to overcome?
Well, just on what I told you about the audio interlacing, the part specs said, "Oh, you can do this," but nobody had ever done that with this particular chip before, and we sort of had to pave the way with that and say, okay, we at the end we ended up, after months of working through the issues, sending a camera to their tech team in India and teaching them how to interlace audio and data onto their video stream. We ran into a similar problem with the image sensor. The image sensor, the documentation, you get this 200 pages of technical specs. And it says, in these registers at the factory, they calibrate the camera and record the location of all of the defective pixels. We said, great, we don't have to worry about that. Get rid of all the hot spots, everything. When we went and read the registers, there was nothing there. And we went back to the manufacturer and said, wait a minute, your specs said that you do defective pixel cancellation. And they went, yeah, the spec's wrong. And so we ended up having to write our own. And now we actually have one that's more advanced than just getting rid of defective pixels. We can actually recalibrate all of the pixels in the sensor so they have a similar response characteristic to the same amount of exposure, because you get 8 million pixels, and thinking that they're all going to behave the same way is dreaming, right? They're all going to be slightly different, but we can make adjustments to every one of those and bring them to within our acceptable level of deviation from the norm. The one we're fighting right now is the FPGA has a bank of memory that can be addressed in two different ways, a low level and high level. The documentation says no problem, you can reach the high level of memory just by following these sets of parameters. What we found is that it doesn't work. It's not documented that it doesn't work. It's not documented why it doesn't work. And we've spent the last 3 months writing fixes for the firmware that's embedded inside the FPGA. So being a small company, we don't have a lot of clout with the big corporations. And when you knock on the door and say, hey, this doesn't work, they go, yeah, go figure it out. So we do.
It sounds like you run across some interesting problems to address there. So you were talking there about having to recalibrate the image sensor on that. Is that something that you guys end up doing at camera assembly time, or is that something that, say, I get my hands on a Sub 2R and I decide for whatever reason, hey, I want to recalibrate the sensor? Is that something that me as an end user would be able to do?
Oh, definitely, because sensors change over time. They also change depending on the conditions. You might be in a really hot environment, in which case you're going to have more excitable pixels. Just over time, the actual sensor changes as it ages, and the characteristics change. So what we've done is made it a user-activated button. Basically, at any time, you pop a lens cap on it, hit recalibrate, and it recalibrates the image sensor. It takes all of about, less than a minute, and it's recalibrated itself. And it will store that calibration until the next time you decide to recalibrate the camera.
That's pretty cool, because you can see sometimes, hot, cold, humidity, whatever, how that affects all that fun stuff. So now you were, and we haven't really talked about this yet, but me and you have talked about this offline, where you're looking at, we're talking about a 4K camera that can do 30 frames per second, or say a 1080p mode where we can do 60 frames per second. Had you run into, I think you guys have some benchmarks out there showing that off, and you want to talk a little bit about why you actually did that benchmark?
Oh, yeah, thanks. So what we found is a lot of cameras use this marketing term up to, and we hate it because it's just marketing gibberish. And when we say we do something, we want to be able to prove to people we can do it. So one of the challenges is, how do you prove you're really 60 frames a second? How do you do that? And some of the cameras that are in the market right now, what they will do is, if they can't process an incoming frame fast enough, they resend the last good one and assume that you're not going to see it. And most people in a live streaming environment like this would never see, even 2 or 3 of the same frame sent at the same time. So what we did is we went out and got I happen to have it sitting here on my desk, a 1963 standard electric millisecond clock. Thing runs at 2 revolutions per second. And we film it and then play it back in slow motion, and you can actually count every single frame is a unique frame. And so we've dubbed the term UFPS for unique frames per second. This is the kind of thing that we want to prove to our end user. If we tell you we're going to give you 60 frames a second, we'll give you 60 frames a second. If we tell you that we give you 4K, we're really giving you 4K, not just 8 million pixels, but a 4K resolution. And so we go through a number of tests to be able to show the end user that we're really doing what we say we do. And I think in the long run, that's what people respect. They don't like marketing, fluff. They want true performance.
Right. Now, actually, I just got a question here via text message. Are you guys making any smaller cameras? I mean, I think I know the one that you guys are going to go to production with is the 4K, but are you making like a 1080 or 720 camera that will that doesn't necessarily have all the higher end features?
So the nature of our design is to provide the end user with a choice of interchangeable camera boards. These just snap on and off of the main motherboard. So you can, as we develop new camera boards, we will be offering those. So you don't have to buy a new camera, you just buy a new camera board and snap these in. We are looking at coming back with a 720p because they have amazing low light sensitivity and high frame rates. So for people who want that kind of performance and don't necessarily want the high resolution image sensors, we're going to provide that. Our image sensor supplier, OmniVision, is coming up with some really amazing camera chips, and we're hoping to get those coming out so we can add those as well. The camera board itself is designed to be able to support 2 1080p and 4K sensors side by side. So we can put a dual camera system on there with one low resolution, low light, one high resolution, or 2 high resolution cameras for stereoscopic 3D. So there's any number of options. As far as footprint goes, going back to our little, what we call the Gen 2 camera, the Piggy, if there was a demand for that, I think we might revive that. We've talked about that, a number of times, but our goal is to get this main camera launched and into the world for people to play with. But definitely, I mean, the little 720p camera is fabulous, and if there was enough demand for that, we would definitely bring her back to the market.
So, well, one thing that we haven't talked about yet today is price point, and I think that's you go out and we look at, say, like a Blackmagic Design 4K camera, and those things start without glass, north of $1,000. Have you guys announced where you're going to be, or what your target price is to get these out to people?
God, every time I announce that, I'm wrong. If the world promises, if everybody listening to this promises not to hold me to this, and I'll explain why in about 2 seconds, we are targeting all-inclusive to be less than $700. And that's a list price. And that includes camera, cables, mount, glass, everything you need to take it out of the box, plug it in, and run it. We're running into 2 problems, pricing-wise. Memory last year, the same piece of memory that cost me $9 cost me almost $50 today. The memory market just went berserk in the last 12 months. So we're trying to find a source of the same memory down to where we can afford it. Same thing's true on the FPGA. Pardon me. The FPGA cost has gone up almost $100 over where we originally were told the price was going to be. So for the first launch of cameras, which hopefully will start the pre-sale in a couple of weeks, we're trying really hard to keep the cost down, which means, probably we're going to launch this as a break-even deal. But it's time to get cameras in the hands of people. And we want to keep the price point down where people can afford it.
Right. And so, I mean, and to kind of address that a little bit, and I think you may have mentioned it earlier, you guys don't have like crazy funding backing on this. You guys are just a small team of people trying to get this thing out the door and address a need in the market.
Well, I think that is the definition of crazy would define our funding. There are three founders to the company. The company has been solely funded by the three of us out of our savings, maxing that, leveraging our homes, cashing in our retirement, you name it. I mean, we have no friends, we have no family, no angels, no outside investors whatsoever. This is 100% funded by the three of us. And we're not, we're not like Bill Gates or Peter Thiel or Elon Musk. I mean, we're normal, everyday people that believe in what we're doing and hope other people do too.
Well, maybe Jeff Bezos will see this and throw some money you guys' way. But yeah, so no, that's pretty cool. I mean, as with anything, I mean, you guys haven't announced sale for this yet, so everybody keep in mind that's where they're trying to get to. So you guys don't go beat Rich up if RAM prices aren't kind to them in the short term, because that's that's not just for what these guys are working on, but that's everything out there. Who knows what somebody's going to want to go buy all the RAM up for next week. But yeah, so no, this camera is shaping up to be pretty cool. So now we've kind of talked about how it's a modular camera. In some ways it's open, and in some ways obviously there's proprietary bits. Are there any of the electronics that are, I don't want to say field replaceable because obviously they are, but let's say I don't like the way you're doing the camera board or some other piece in there. Is there plenty of information going to be available so that I can make my own part for that and then use the rest of the camera?
You don't like our camera board?
I'm not saying I don't.
I mean, we spent gazillions hours. It's like, no, like, I'm teasing. The camera board is actually one of the things, that we will definitely provide you with all the information necessary to build your own. There's nothing proprietary or secret or special about the camera board. We purposely did that because we knew that there may be people, for instance, doing research who have a very unique sensor that they need to put on a camera, and they don't have a huge budget, but they need the functionality of a sensor. It wouldn't make sense for us to build a camera board for a sensor, but I have no problems giving you the Gerbers and saying, here, this is how you need to make your camera chip fit on our board, and you're responsible for interfacing with that chip, but by all means you can design, build your own camera board. We've even gone so far as, if you don't like our housing, which will make Serge very sad, you can yank the boards out of the housing and put them in anything you want, so long as you meet the physical, electrical, and thermal, very important, the thermal aspects of the board, then you could put anything you wanted. So again, the idea is to not restrict the end user, but to empower the end user to just have fun, create new and interesting things with this.
So no, it sounds like a very flexible platform indeed. So of some of the cameras that you guys have out there already, are there any that people have deployed into interesting places? I think you told me about a few of them.
Yeah, we have one right now that's being used to watch ice crystals grow in a refrigerated storage container. Um, and that's so one of the problems that they have is that the lenses on the cameras that they use tend to freeze up. So we got together with PSC, which is the company that has designed our passive cooling in the camera, and said, how do we solve this for them? And we have a lot of heat that comes off the FPGA. That when you're running 4K at 30 frames a second, you're going to generate a lot of heat. So what they proposed is using light pipes, or not light pipes, heat pipes, to take the heat off of the motherboard and basically make a defroster for the lens. I mean, you've got that heat already, right? So why not pump it to the lens and use it for defrosting the lens? This is kind of the cool stuff you can do with our camera. We're also working on a unit that potentially, if things work out, is going to be used in submersibles like the deep sea ROV for the Nautilus. Our optical engineer, who is in Florida, has done a really interesting design. I don't want to get too far into that, but if it works, when we prototype it, it's going to change the way people do underwater photography. So I'm kind of excited about that.
That's pretty cool. So we covered a fair bit of topics, Rich. Am I missing anything about the camera today?
Let's see. What are you missing?
You have one you can hold up and show everybody.
I've got a mock. Believe it or not, I just have a mock-up because all the cameras we have, we pulled back from the field. They're getting some last-minute updates. I should have had one this by now, but the camera that I use went to OmniVision for review. But this is the camera. Oops, get some lighting on there. But
Yeah.
it's a really small device. It's passively cooled for people that want all their gear to, at least be color coordinated. The side rails are interchangeable. These are dovetail slots in the sides, so you can rack mount them. You guys probably love rack mounts, right? And then we have a standard 1/4-20 on the bottom. The camera weighs in about 450 grams.
Heavy of a camera, either.
It's the passive cooling. The passive cooling is what really requires a lot of thermal mass to get the heat out of the box and away from the electronics. And that's something we spent a lot of time working on because we know with our earlier camera development that heat was a big problem. And when you have microphones on board, this has dual microphones on the front, and then it has a headset jack on the back, so you can actually wear headphones and a boom mic. And if you have a fan on board, all the audio just sounds like you're sitting in a dentist chair getting a filling drilled. So we had to go to a passive design, and that brings in some thermal mass that we have to have inside the camera to get the heat to the outside. So the whole casing is an integrated heat sink. But we thought about that and said, there may be people that don't need microphones or don't care. In which case we have 2 PTO ports on board that allow you to get 2.5 and 5 volts. That's isolated power, so you can drive active cooling if you want to drop the weight down. You can also power just about anything else you want off the board on that power supply. Because one thing I always hated was, when you're working on an electronic project and you need power, and then you're walking around looking, okay, what cap or what resistor can I solder a wire on the back of and hope I don't ruin it to get some power to drive whatever else I've got. We didn't want people worrying about that, so we gave them isolated power. The other thing we did, which is really cool, I don't know if we can see this, is, oh yeah, on the back of the camera board, you'll see a row of pins. Mm-hmm. There's 16 I/O pins there that are user configurable, because we don't know what you're going to do. So if you want to drive, for instance, a powered, pitch yaw roll mount, If you want to drive powered optics, all the pathways and connections are there for you to connect your devices to that bank of pins and then drive whatever you want from it through the FPGA. So that's kind of a cool aspect of that.
Yeah. So along that line, the next question that any hardware hacker is going to have is on that isolated 5 volts. How much power is available there to drive, anything that you're going to be adding on that may be controlled by those IO pins?
Right now, I think the max on that is about 3 amps.
A bit of power there. That's a fair bit of power available for a project.
Yeah, I mean, you're not going to get it over USB. You've got to use, we've got an auxiliary power input, but I mean, if that's what you need, you can get that off the isolated power supply.
That's like super cool. So,
I think another thing that's important to note is that, somebody was asking us the other day, well, how many hardware engineers do you have? And it's like, 1. How many image processing engineers do you have? It's like 1. How many optics guys do you have? 1.
how many of those guys are the same person?
No, actually, those are 3 separate people, believe it or not. And they're all very talented in their own ways, but there's only so much somebody can do in 8 hours, right? Or actually, I don't think anybody here works 8 hours. It's more, we joke, we work 25/8 in this company. But since last December, when we brought Roger on board, we have done some amazing things with making utilities for the image processing pipeline. And we have a full suite of UVC controls. We're moving those on board. We're adding more and more controls every day. And the cool thing about that is when we make an upgrade or an advance to one of the utilities, that's simply a user upgrade to the firmware. So we can issue out an upgrade to the camera, and you can say, oh, I want that chroma noise to, denoising application, and you can download it and add it. The hope is that when people start to play with it, they're going to come up with their own applications, and people will be able to utilize those and load those onto their camera to get different functionality. So it's, again, we try to make it as useful as possible. There's 2 things I haven't mentioned. I always forget this. We have a 3-color LED indicator on the front. And every time I think about that, I think, my God, why do we bother with that? It's time to ditch that, right? And as it turns out, when you encapsulate a camera inside, for instance, a bottle that's going to go to the bottom of the ocean, right? You have no idea whether the camera is running or not. You don't know what the status is. So people want to be able to program the LED to tell them what status and what function the camera is in. And so we said, okay, well, instead of us being in control of that, we'll give some basic functions, but we'll also give you access to control the LEDs, to any way you want. And therefore you can make it tell you what you want it to. Or if you don't like the colors we pick, if you want pink as the record on light, you can do that as well. And then we have this cool thing in the back. There we go, right in the middle. It's a GPIO port, and it allows you access bypassing the FPGA and going straight to the camera. And what you do with that is that allows you to get a strobe signal out and a sync signal in. So if you have 27 cameras and you want them all running at exactly the same speed on the same frame at the exact same time, you can use one camera as the master and the rest of the slave, or you can use an external Genlock system, or you can even go so far as to sync the frame rate with something external, say a bicycle pedal or a piece of machinery or a conveyor belt, so that the frame is always exposing at the exact right time for when you want it to be synchronized. So it was one of the cool aspects that we added onto the camera.
Actually, I
And
just thought about something.
that's just a cool camera.
Oh, no, it's a super cool camera. So one of the things that we actually haven't talked about, and we probably should since we're talking about 4K cameras here, is what kind of compression, if any, are you guys doing on the camera, and why did you guys decide to do that?
So right now we have basically three formats that we support on the camera. The first is a YUV format, very standard, format. But at 4K at 30, that's more data than you can squeeze over USB. So the other format we use is an NV12 format, which is Microsoft, basically their MMF format. And then we have our own version of basically a cinema raw, which is the data off the sensor prior to it being demosaiced. So it's the same kind of a thing you would get with a D3 or an Adobe Cinema DNG. It's the same type of information. As we move forward, we're hoping to be able to provide a Cinema DNG format as well. We're also working on our own onboard H.264 compression. When we finally battle through the last challenge on the H.264, again, that's upgradable if you get the camera and it doesn't have H.264 on it. When it's up and working, you can simply upgrade and add that to the camera. We want to give the user the ability to determine how much compression takes place. So if you want just the minimal amount of compression to get 4K over 30 over USB, you can do that with a less than 10% compression. If you are trying to cram this thing down so that it will, you don't burn up your memory and run out of space quickly, you can up the level of compression. Writing an H.264 algorithm that is compact enough to run with no latency on an FPGA turned out not to be an easy task. But I think it's pretty amazing we're as close as we are to that.
That's cool. Yeah, I guarantee you that Tony and some of the other FreeSwitch guys can attest to how dealing with video codecs is, shall we say, fun?
Yeah, no. But yeah, this kind of the beauty of this camera is as we go forward, if people need a different format or there's enough demand for it, or you want to install your own format. I mean, that's, you may have a very specific format that you need the video to come out at. That's fine if it doesn't make sense for us to design it and implement it. We're not going to prevent somebody from being able to design and implement that and put it in themselves.
Cool. So, yeah, I think I'm about running out of questions here, and you covered just a ton of information on the camera here. So where can people go, Rich, to get some more information about the camera or to stay up to date on when you guys, as you guys have more developments on it?
So we've got a website, which is sub2r.com, and there's a sign-up page on there on the reservation tab that, you can be on our mailing list. People who do reserve a camera, there's no obligation at this point, but when we launch the pre-sale, those people who reserve a camera will get a discount above what anybody else buying a camera will get. And then we have a YouTube channel, which is Sub2R. And we post our more recent demo videos. We're not professional filmmakers by any means, but we have fun going out and seeing just what our camera can do. The last couple of times we took it actually out of the lab and into the real world, which was kind of fun. But we are getting very close to the pre-sale launch, and I think that's exciting for us. Our goal will be to pre-sell enough cameras that justifies a minimum run, which I think is about 500 cameras. And if we can do that, this whole thing will take off finally.
Yeah. So, question on that actually, real quick, and then I think this will be the last question out of me today. Have you guys had fun finding uh, contract manufacturing, or are you guys going to try to run these cameras in-house?
Wow, contract manufacturing that runs the gamut. I think I've probably been to, I don't know, 20 or 30 of them here in Silicon Valley. We finally found one that I think really understands what we're doing and is willing to work with us. Most of the rest, it's a tough business. And the first one that we met with, the first cameras were actually built on a full scale production line by one of these multiple huge giant CMs that promises everything and then subs it out and delivers nothing. And so we sort of drank the Kool-Aid and got burned on that one. But that made us smarter for this time around. And I think the company that we're going to work with is really dialed into what we want to do and willing to support us. And of course, our key question was how many units per month could you support, provided this thing takes off. And when they told me 10,000 units a month, I went, okay, well, then wouldn't it be nice to have that problem?
That's always a good problem to have. But yeah, no, so that's cool. I mean, I've looked at doing some short runs before of just various projects, and it's always fun trying to find somebody that you can get started with and will actually, help you through that process, because I'm not the best, design for manufacture person out there. And I'm going to guess that I'm not the only person in that boat, even though I can come up with something that'll work.
That's probably the most important thing with a CM is building that relationship, because we know about cameras and we know about imaging pipeline, but we don't know about board design. And they've made millions of boards. And we look to them to come back to us and say, guys, if you just move this part over here, or you change this one part, it's going to be a whole lot easier and a whole lot better to build this product. And we're open to listening to that. We want that kind of communication. One funny story, we had a target price that we wanted these guys to come in at. And there's NRE, which is their tooling, and then there's the cost to actually build the unit. And this one company came back with the first time with this price that was way too high. I said, my God, that's more than I'm going to sell my camera for. You can't charge me that much to assemble it. And they said, okay, we'll fix that. And the next bid they came back with, the price was amazing. I mean, it was like, I couldn't believe it. And then I looked at the NRE, and they had stuck an additional $50,000 in NRE. And I said, but who's going to pay for that? I got to pay for that with the cameras they sell. And they said, well, that's not part of the cost of the camera. And I said, whose pocketbook are you working out of? Because whether it's NRE or whether it's production, the cameras we sell has to pay for that. So, they play all the tricks in the book, and, finding one that you have a good relationship with is a lot of work. But I think when you find that partner, it's really a good place to be when you're building something like this.
Yeah, no, it's good when you can find that partner, because like you said, moving a part, or don't use that part, use this part over here, it'll save you 12 cents a unit. And people say, well, just 12 cents, it doesn't make a lot of money, but it does when you run 1,000 cameras or 10,000 cameras. It really impacts the final price.
Well, and like we have these two little things called keystones. I don't know if it'll show up oh yeah, they do. Yep. These little guys right here. Whoops. There we go. Right there. That's for mounting on the original design, for mounting the camera board to the motherboard. 75 cents a piece, and probably 25 cents a piece to be mounted on the board, because they have to be hand placed and then hand soldered in on the board. PSC, our housing guys, came back and said, we can make a change to the front plate where you now screw the camera board to the front plate. It'll make it easier for the end user to swap camera boards. It'll make it stronger, and it'll save you, basically $2 every camera. It's like, wow. I mean, definitely willing to listen to anybody who's going to give us, good engineering advice. So we really take pride in the partnerships we've been able to build with companies like them. It's made it easy for 5 people to make a company work.
Yeah, cool. So, all right. Well, Rich, I think we're running up against that time today. So if there's any last things you want to get out there, let's go ahead and get them out there real quick.
Just that we're just on the verge of going to the pre-sale. We appreciate you guys for having us on, and anybody has any questions, please feel free to reach out and send me an email. Always good to hear what people want to do with this and hear their ideas and thoughts. So again, thank you guys. Appreciate the opportunity.
No, thank you for coming in and joining us today, Rich. I've been watching the camera for a little bit of time now, and I'm on that reserve list, so I'm just waiting to have the opportunity to get my hands on one to play with it and check it out.
Well, we're going to send an eval one to you and Michael and let you guys play with it. So
I have to fight over him with it to see who gets to keep it the longest. So, yeah, I'm excited to see that and get my hands on it and play with it and let you know what I think. And for anybody else that wants to check it out, go to sub2r.com. Like you said, there's check out the link there. You can reserve a camera or get on the waiting list. And Rich actually sends out newsletter every now and then with some really cool stuff on there and let you know when they've done new videos and updates and that kind of thing. So definitely go check that out. Again, Rich, thanks for coming in here today. Also, for you guys that are going to ClueCon and you have not registered yet, head on over to ClueCon.com. I think there's just another day or so left on the discount code that's up there. You want to get in on that while you can before that discount expires and the price goes up. Also, if you have not got your hotel reservation for ClueCon, you want to get on there and get that in there right away. Also, check out ClueCon.com for other information on what's going on. Don't forget, guys, follow us on Twitter, like us on Facebook, and if you're watching us on YouTube, click that subscribe button down below. You'll get the new videos as they're posted. Thanks, guys, and have a great week.
You've been watching ClueCon Weekly. Tune in every Wednesday at 1 p.m. Eastern Time, or visit us online. Please follow the FreeSwitch team on Twitter and Facebook by visiting our site at freeswitch.org.
All right, and we're clear.